Hello everybody. Today we'll be working on merge to sort lists using the UMPIRE method. In this problem, we are given this example here where we have two separate lists and we have to make sure that the items are returned in an orderly fashion. So we have two ones, a 2, then a 3, and then two other 4s. So what are the boundaries of this problem? So in both lists, there are a possibility of 0 and 50 nodes maximum. So that means that a possible list could be empty, empty. That would be one of the edge cases. So in this point, we would return nothing. Another edge case would be to have items in one of the lists while the other list has nothing. All right, and lastly, an edge case would be where both items have 50 items, but I don't think that is very necessary to test. As long as we have two lists with items that can be added together, I think we are good for 6, 7, 8, or 50 items. So the values are between negative 100 and 100. So that means that will not impact us at all. We do not have to worry about it doesn't really matter all that much, the value of the node. So, and lastly, both list 1 and list 2 are sorted in non-decreasing order. So both lists are sorted already. Both lists must be sorted. So both lists must be sorted. And max and min 0, max 50 nodes. Those are important parameters to understand when we are doing this problem with our cases. Okay, so with that, I think let's come to an idea about hypothesis about how we're going to do this, and what the time and space complexity. So I presume that we will have a match. We have 2 pointers, and with 2 pointers, what we'll do is we will have one pointer in one list and another pointer in another list. With these 2 pointers, we'll be able to check which item is larger or smaller. And doing so, we will go to the end of the list and add all the items together. My hypothesis for the time is that we're going to go through both lists completely. So that's going to be O of n time. But in this case, we have a maximum of 50 nodes per list. So that's O of 100. Therefore, it's an O of 1 operation. However, if we increase the number of nodes to n, it is an O of n operation. So space, we are going to use no additional space here. Because what we're doing here is pointing nodes to one another. The space that we were given already is used exactly this. It remains the same. So no new space was needed for this problem. If, however, we were to do this as an array, we would be using new space because we would have to generate a brand new array with two sorted from the 2 sorted lists. Okay, so let's go to our planning stage. So our plan is to, 1, always create a dummy node. A dummy node is so that we can create a dummy node to point at the first item. That way, it acts as the head of our list, or a dummy head. Well, acts as the head of the list. So, and dummy node.next acts as the head of the list. With that, we can now also create 2 pointers. Let's call that like list 1 pointer and list 2 pointer. This will give us a clear understanding rather than having I and j. With that, we will iterate the 2 pointers through both lists until one of the pointers reach the end. Lastly, integrating the smallest value and moving that pointer forward. Lastly, we will integrate the remaining pointer into our list, into our linked list. Okay, I think with that, we are good to go. Instead of list, I think we could do linked list. I think that's a little bit verbosely more correct. So let's implement the solution. Looks like we're running out of space, so we're gonna go to the top again. Okay, let's implement this. Let's create the dummy node. So dummy node. Let's set that to be equal to list node. And we start with a value 0. And we have a next of nothing. So let's just set it as the list node. So we have list 1 and list 2. We could just directly use list 1 and list 2. And well, let's do that and see if that works for us. If it doesn't, let's make it a little bit more verbose for us. So while list 1 and list 2 if list1.val is less than list2.val, I don't think that does not work for me, because we're talking about list instead of pointers. That's just not working. When we talk about, even though it's more verbose, I believe that having the word pointer helps us like think about this without extra brain power when we're coding, because that way we know that it's a pointer, not a whole list. So if it's smaller, also we need a current. So a current pointer, current.next is equal to list1 ptr, and list1 ptr is now equal to list1 ptr.next. Also, we need to set current to be equal to current.next, because that way we don't overwrite current. With that, we can do else, and we could run this similar code. So current.next is equal to list2 pointer, and current is equal to current.next, and list2 pointer is equal to list2 pointer.next. With that, we have advanced. We have done the first 3 steps of creating a dummy node, creating 2 pointers, and iterating through the 2 pointers, integrating the smallest value until either of the 2, whether one of them are eventually become a none. So if list1 pointer, if that's true, that means this has an item. So we're going to integrate this. Current.next is equal to list1 pointer. Else current.next is equal to list2 pointer. And with that, we can return our dummy node.next. And with that, I think we have completed this problem. And we are ready to run the code and submit. So we have an error here, but I think that's pretty clean. And so once we're ready, let's review this code. In our review, let's just go over this example here and check that out. So we have 2 pointers, I and j, and we are at the beginning. So we have a dummy head, dummy node, and that's going to point at our item. So this is current, and of course that moves forward with every node. So current.next is the smaller of the two. So given this particular state, we're going to take it from list 2 first. So we have a 1, and we move everything forward. So current goes to current.next, and the list 2 is moved forward. So now we compare 1 and 3. 1 is smaller, so we put in the 1. Then what we do is we move the current and we move the I. Now we have 2 and 3. So 2 is smaller than 3. So we move the I, move the current, and we keep going. So now 4 and 3. Well, 3 is smaller, so we'll point at 3. And now we move J and we move C. And 4 and 4 is equal, so we'll take the 4 from the J. So now we move it forward as well, and now J is now none. So that means that this part of the loop is complete, and the remaining item from list 1, we take that pointer and we take the 4. We add that in, and we just submit dummy.next, which is the head, and that's okay. Also, now that we have done that, let's try nothing. So suppose we have nothing at all, and what happens here is both are none, and nothing is here, and dummy.next is still pointing to nothing, so we return nothing. Perfect. And if we have a single item, this is skipped, and we just say current.next, which is dummy.next, which is empty at this point. It will point to whatever is remaining, which is 0. It can even point to the entire linked list. So now this will point to our item called 0, and we will return that. And that's it. So perfect. This will work for all of our edge cases. So let's submit the code and see how we do. Perfect. With that, we have solved this problem called merging 2 sorted linked lists. And if you enjoyed this video, like and subscribe. Want more videos, check the link in the description below. Thank you very much. I'll see you in the next one.